So, first of all, I would like to welcome all of you to our session on the challenge and opportunity of genetic improvement in aquatic animals and in livestock. I'm delighted to serve you as a moderator today. Actually, I come here having two duties. The first one, I represent the president of KU Alumni Association under the Royal Patronage. This seminar series is part of our mission aiming at contribute knowledge and experience from KU alumni and also other scholars to the public. So we are very happy to organize this event today. So before we start, may I kind of sincerely ask you, are there any foreigners in this room? Maybe, you are foreigner? Do you know Thai? No? Okay, fine. So we conduct the seminar in English. You know what's happening yesterday and early this afternoon when we start talking in English and then the foreigner is in the room left. So please stay with us throughout the seminar, okay? You know, even though we speak English quite fluent, but sometimes expression, insightful or deep expression sometimes is a bit difficult. So no problem. Thank you very much for joining us. So first of all, I will let you know what we are doing this afternoon. Actually, there are two sessions consequently, but what I'm going to do is that we will running the first session on aquatic animals first, and then the extra speaker for the livestock will join us in the second session. Anyway, all of the panelists will still be here in order to make a group discussion. So then maybe it might give the better or more fruitful discussion. Okay, so first of all, I would like to introduce my speaker or my panelists today. I'm so proud to present you Kun Amon Leung Manit Chai. He is a managing director of Manit Genetics Company Limited. He got a bachelor degree from my department. I used to teach him, and he said I'm a good professor. And he went to AIT and got Master of Science in Aquaculture and Aquatic Research Management. At the moment, he is the managing director of Manit Genetics Company Limited. Please give him a welcome.
Good afternoon, everyone.
And the next panelist is, I can call you professor right now. He's actually his qualification past the professorship, full professorship, but still he has to wait for the royal appointment. Yeah. So I can call you professor now. Professor Dr. Skon Kunawut Rithiron is a professor at Department of Animal Science, Kasetsat University. He was graduated from Kasetsat University from bachelor degree to PhD, right? But he has a lot of experience outside the country, got training in Florida for around a year, and then working for the regions, for many countries in the region. And one more thing I would like to tell you is that just last year he won a national award in the best
Scientist.
scientist award. Yeah. So today I am so proud to have two of you on the panel today. So please give warm welcome to Dr. Sakar.
Thank you very much.
So what we are doing today, I will kind of give a question for the first round speak. I will let Kun Amon describe about his work a little bit in order to know more, and then ask some questions to Dr. Scott, and then we will have another round. So the first round will take around 15 to 20 minutes. It depends. Yeah? Maybe 15 minutes. Okay? So my question is, since I'm trained in fish genetic improvement, so I know that doing the genetic improvement in aquatic animals as a business is not easy. It requires a lot of money, a lot of investment, a lot of knowledge, a lot of management. So why do you decide to go for this business? And how do you start? And what's next? So very big question. Okay.
Okay. Good afternoon, everyone. Again, my name is Amon. I'm so proud to be here as Kasesat alumni representatives. As Professor Uthairat said, she has been a very, very good lecturer, but I was very bad at that time.
Oh, really?
That's why I got only D plus from her subject. It is still, I always keep in that mind that I was very bad. But anyway, we got through that period more than, I think, getting close to 20 years. Getting close to 30 years. So today, I actually, according to her question, I would like to explain a bit what our work is, and I will reply and try to get back to Professor Uthairat's question afterward. Okay. So actually, I am managing director of a family business company, which called Manit Genetics or Manit Group. So we've been in aquaculture business for more than 50 years, since 1966. And at that time, we started with catfish, not tilapia. Okay, but because of it could be we can call opportunities, or it can be a threat. That the catfish business that my father established in 1966 was not that very fruitful in terms of business. So we started with the catfish in 1968, but in 1968 we started a catfish business, and then later on we moved to another province. It's called Phetchaburi, where we start tilapia and shrimp culture there. Okay, he bought a big pieces of land at that time, almost 300 hectares, but because of the shrimp was not success as well. We still growing shrimp up to now, but I would say that shrimp business is really up and down, and very difficult to predict the outcome of the business. So at that time, we start to look at other alternatives. And then we found tilapia is one of the best opportunity, the best animal that able to grow properly in that area, which is a brackish water. So we start tilapia business, and then we, with the help of AIT at that time in 1993, AIT brought a new technology which is called sex reversal technique to change all the sex from tilapia from female to male. So we are able to get all male population from that technology. So we acquire that technology, adopt that into the farm. Then we start tilapia hatchery in 1993. And after a while, we realized that, okay, You know, before 2007, when the way that we get the broodstock is to get from Department of Fishery or AIT sometimes. And I was very checking, you know, when I was visiting our customer. And then if they gave us a positive feedback, let's say, this year your fish grow very fast, your fish got very high survival this year, then I'm a bit, okay, shaking. But I don't know what we have done, you know, because we just bought fish from Department of Fishery. We do very simply selection at the farm, and I think everyone know it. Everyone do the same as I do. So, but I don't know why our fish is better than others. So I was checking, and the next year I come back again. The same customer said, "Oh, Amon, your fish was not good. It was very poor in growth, very poor in survival." Then it is even worse, checking, because this year I don't know why it's worse than before. So at that time we start to think that, okay, if we're going to make it serious in the business, we have to be able to control something, at least the quality of broodstock. That's why we start over a breeding program with the help of I would say that the greatest aquaculture consultant on animal selection, which is called Aquaforce Genetic Center at that time. They were the largest consulting company at that time, which is, we believe that they have the best knowledge. So with the help of Aquaforce, we set up our own breeding program in our farm since 2007. Until now it's already, how many years? 17 years, right? 2024 now. And later on, we started MOU with Kasesan University, which is we would like to develop our team in not only in experience but also in the knowledge, ground, make sure that everything will go smoothly. So we are able to develop our team efficiency and competency as well. And then we reorganized the company. Then 2019, with the collaboration with Kasesan University again, we get IPRS technology, which is approaching by Auburn University. And recently, just last 2 years, we also renewed MOU with Kasesan University again for another 5 years. We set up a laboratory. Later on, I will show you some of the pictures. Yeah, that's it. So that is how our company come to this point. Okay, this is I give you a brief market that we are involving now, mainly on the seed production. We are supplying more than 95% for domestic consumption, and the rest for export. But I would say that just only 5% to Laos, to Malaysia, Vietnam, India, Philippines. Mostly are in Southeast Asia. This is how our genetics nucleus look like, Tilapia Genetic Center. So basically, in our own farm, we have separate clearly into two department. One is a nucleus, which is mainly for research work, and then a production site. So those two groups will be totally separated, not involved at all in between each of them. And there's a lot of details how to do it. I think Professor Sakon or Kasesan University can give anyone that interests much more in details when you are taking his course in university. So I will not tell you how it has been done, but I'm going to show you the outcome, okay, of long-term breeding program that we have been doing so far. The result that I'm going to show you today is only in the growth trait, okay? But actually, we are able to select animal, not only a single trait at a time. We can do multiple traits. We can do growth, we can do general survival, specific disease resistance. We are able to do salinity tolerance. So we are able to select animal according to the market, upon to what actually we interest. We are able to select at the same within a generations. Okay, so I'm going to show you what if you run a proper breeding program and you select the best animal on growth. Might not be the best animal on growth, but the best animal that having good growth and other trait at the same time. Okay, this is the. I'm not sure that how much you get used to with the distribution curve, but let me explain. I'm not sure. Okay, it is the distribution curve that giving. Okay, this is normal distribution curve, which is giving you an idea how the growth, how good and bad growth of the population, animal in the population. Some of the fish. Let's start from this is a breeding value, not a physical, not phenotypic information. It is a breeding value. Okay, so let's start from zero. Zero. What does zero mean? Zero is mean. Okay, let's say this is the mean of the growth in this population is 600. For example, let's say 600. So some of the fish that grow pretty good, they can be 700. Some of the fish that grow very bad can be 500. Okay, is it make sense? Okay, please remember this fish. This fish performing the best actually in this generation, and somehow they are about 600 something, 650 maybe. Okay, this is the best one, and the worst one will be around here, around 500. Okay, so basically, when we are selecting the fast-growing animal, we have to select this part of the group. Okay, faster animal to be the future broodstock. Okay, and if you select the fast-growing animal in the group, this will shift your growth in the next generation on to the right-hand side like this. Okay, and this is comparing between N1 and N2, generation 2. This is generation 1 and 3. It's 1 and 4, 1 and 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. If you remember, this is the fast-growing animal in last 17 years ago. But recently, when we develop properly with the proper selection in a long-term period, okay, almost 20 years, look at the worst or the slowest growing animal in the latest generation. It's by far ahead from the best animal in last 17 years ago. So, and you look at the similarity of the population in terms of growth, they are pretty much similar than when we start. So this is the outcome from the growth only. And not only the growth that we are focusing, actually other traits also very important, because reality, when you're talking about growing animal in open system, in cage, in river, in reservoir, basically the farmer have to face with so many problems, with so many diseases, with virus disease, with bacteria disease, changing in different from season to season as well. Such as in summer, they might got problem with streptococcus. In winter season, they got problem with Francisella or Flowbacterium. So many bacteria that are already exist in the open system. So the farmer has so many challenges to be able to survive, to get the best survival from that environment. So that's why we set up another facilities to be able to select the right animal to grow in reality. So this is our new laboratory just set up for another 2 years. But before that, we have a deep study research with Kasetsart University as well, with Department of Fishery. With that collaboration, they allow us to set up a small wet laboratory inside the university. And then we got a consultant by the university, by the professor in Department of Fishery, help us. And finally we learned that, okay, if you're going to do this kind of experiment in long term, you might have to set up by your own self. Otherwise, that's a bit limited for using the university facility for a long term. So that's better. That's why we, after 5 years research with the university, finally we made up our own self for the laboratory. We'd like to show you some of the pictures inside where we have microbiology laboratory. We have molecular laboratory. We are able to diagnose most of the viral and bacterial disease in tilapia and in other fish as well. So this is the place that we run routinely work with not only for the experiment with the new challenge for the selection, but also from the routine work. This is the Streptococcus challenge test that we do with our own population, but not population, with our test animal. Because anyone that already get out from our nucleus and been tested with any kind of disease, we will never bring them back. We just gather the information from them only. This is the wet laboratory, and this is why they are conducting challenging experiment. And this is another room, experiment room, which is called preliminary room. That's it. The pictures that I prepare all. Get back to your question, why we start. I think I already mentioned. We, as a business entrepreneur, we know that if we would like to be able to do our business in the long term, we really make something different to others. The reason that I was checking when the farmer asked me whether I did good things, whatever I did bad things to them, I was checking badly because I don't know what we have done, why it's good, why it's bad. So if we do not know why we are good, why we are bad, so you cannot run a long-term business. So that's why we believe that be able to control at least our broodstock performance, then that can secure our business. So our commitment in the future, for sure, we keep doing this, doing better and better breeding program for ourselves, but not only for tilapia and red tilapia now, we are expanding to other species as well. So this is what we are. And the last question you asked, where and when this job gonna finish, right? I tell you, before I start the breeding program, I have been thinking who gonna be in the next generations to run the breeding program, because it is something like never endless. It is endless job. Once you start properly, you cannot end it, because once you end it, all the value that you have been investing since in the first day will be gone immediately. So that's the first round, Doctor.
Yeah, thank you very much. I'm so excited with what you show to us. Anyway, I'm not asking a question right now, so let's go to Dr. Skorn. Dr. Skorn, by nature, he is working on livestock. And why do you decided to go to aquatic animals. Again, wait.
No, I just.
Yeah. I will ask you the whole all question before you start answering, and then second question is that by doing both groups of animal, do you see what's difference? What is the problem, or what is the advantage of aquatic animals when compared to livestock?
It likely the question is give more weight to aquatic animal, right?
Yeah, right.
So the first question is why I am here with the aquatic animal genetic improvement program because of Professor Uthairat. Okay, 14 years ago she brought me into NASDA to support a breeding program of monodon black tiger shrimp at that time. And many people are still confused about keeping diversity and do the genetic improvement program. In terms of genetic improvement program, we, like Kunamon told you, we move mean of the next generation to be better than the previous generation. We also do keep keeping the diversity, but the priority is less than moving the mean. Why? Because we need to support the market demand and compatibility of the producer. Okay, so that is the key point why I am here with the aquatic animal. And which one is more difficult? I think it's, for me personally, it's not difficult, but it is my challenges. Because if you do a genetic improvement program with a species, the only thing that you need for the beginning is to understand normal behavior, habitat, and everything relating to that particular species. If you do not understand, you cannot do any genetic improvement program. Why? Because you need to understand the cycle of the animal. I mean, from generation to generation, how they perform, when they mature, when they should be appropriate mating, and also what factor that affect the trade that you target for the market. Okay, all things of this need to be considered in the breeding program. Okay, the other question I do not remember now.
Oh, the question is what is the difference?
What the difference? Like Kunamon always say to everyone, in livestock we can see each one of them, but in aquatic animal they are in the water. We cannot see them unless we harvest and then look at them. And the most challenging thing is how do we know that that is the animal that we are considering. So the most challenging thing is how do I make the identification number for each one of them. In cattle, we can do ear tagging, okay, or tattooing. Even in chicken, we can do wing band with the number. But for fish, but in particular, we need to consider the technique or some equipment that put inside its body, and then we can detect which one of them. Okay, fish is easier than shrimp. Shrimp, currently we try very hard to find a way to make it can be separate individually. Currently we use family tagging with the elastomer. Okay, so technique like this we need to consider when we design an experiment to test their performance, and then we gather our record to be analyzed with the pedigree to come up with the estimated breeding value for more accurate selection. Okay. Even now, the current technology allow us to do the genotyping at the genomics level. But still, we need to understand them more about the genomics associated with the trait. So we cannot make the right decision yet what we should do. But unless we can utilize those genomic information for increasing the accuracy of selection by combining them with the pedigree and performance information. Okay, the rest is waiting for us to understand more how they associate it to each other. I mean the SNP and genes, and also QTL, and we need to do the analysis for detecting the association between the target gene and the marketed trait. Okay, this is the key success. If we do not have this information, we might make a wrong decision for the operation. And with the genetic improvement program, we do at present, but the result come out for tilapia is likely a year after that, but for cattle 3 to 5 years. Okay, so we need to do only the right decision before matching male and female together. Something like that. Yeah. So in conclusion, the most challenging thing or the major difference is the way to identify the individual animal. Livestock compared to the aquatic animal.
Yeah. One more thing I would like to add. The big difference between aquatic animals and terrestrial animal is the aquatic animals are poikilotherm. So the phenotype is controlled by genotype in a smaller percentage. Averagely about 30% only. So that's a kind of difference. And to my opinion, maybe the management of the broodstock in aquatic animals we do by population. Right? Do you agree?
Yes. Actually, I do agree with Professor Thailand. When you compare doing genetic improvement program between livestock and aquatic animal, normally the livestock production are dynamic. I mean, we cannot separate generation to generation like tilapia or shrimp. But in aquatic animal, we decide to set up the period of producing this animal to replace the previous generation. Like during these seasons, we do the productions of the next generation by mating them and then waiting them for transformation from this state to the other state.
Yeah. So actually, we can use the core technology.
Yes.
Yeah, just only the small management difference that we have to concern. Okay, so let's come back to Kun Amon. I have so many questions, but with this limited time, I'm not so sure this one is the best. I'd like to have your idea about the genetic improvement industry in Thailand. Do you think it can be expanded? Do you think more company can be established? What will be the obstruction? What will be the opportunity for them?
Okay. I think in order to answer your question properly, I should give you a bit more on disadvantage and advantage of running aquatic breeding program. Okay, if you compare with aquatic and livestock breeding program, the difference from what I see, okay, firstly on disadvantage first, as the Professor Scott already mentioned, visibility is quite difficult. Okay, fish swimming in the water. So once you stop them, they will be there, and you cannot identify them clear unless you have Bitec inside or some kind of pit or tagging, maybe color tagging or whatever to be able to identify. So it's not easy. They also be influenced by water quality, which is always changing from time to time. Okay. For aquatic animal, I would say that if you talk about aquatic animal, you have to think about what kind of species you're talking about, right? Sometimes people talk about fish, they're talking about Nile tilapia, talking about red tilapia, they have catfish, they have shrimp, vanamai, black tiger. Varieties of aquatic animals are so big. So whenever someone would like to start over a breeding program, they have to think about the market that they are going to, the market of each species. Even there, it looks interesting to improve even, but if the market is too small, then it's not feasible to run a breeding program for that particular species. And on the disadvantage, another disadvantage is before you start over the breeding program, you have to really understand the breeding behavior of the animal. In the past, there was some species that I am really interested, but when I was thinking how to mate them individually, it sounds very difficult. It would take so long time to be able to do that one by one. So that might not be feasible as well. Such as one of the species that mate individually, it is Macrobrachium, or how do you call it in English? Not giant. That is freshwater prawn. Okay, because the behavior of the animal is they are so aggressive for the male, and then if they don't like this female, you cannot force them to breed. So this is one of the difficulty that we found. Like in the past, we used to have very beautiful male. They grow super fast. They are very strong, but they do not breed. There's no any female that they like. Then finally they're getting older, so we cannot catch up any advantage on that animal, something like that. So, but the beauty of aquatic animals, which is different to livestock, is they with quantity, they are so big comparing with livestock. One fish can produce at least 1,000, 10,000, depending on species, can be 100,000 animals at a time, at a breeding, at a spawning. So intensity of selection will be extremely high in aquatic animal, comparing with chicken or cow or so whatever, livestock or terrestrial animal, that breeding maybe 1 to 10 animal at a time only. And and the life cycle as well. Like I don't know how many years that a cow can breed, but tilapia can breed within 6 months. So we can run a cycle of breeding a cycle of tilapia within 8 months. This is what we can do. But some fish also take quite long, like salmon. It takes 4 years for female to be able to get ready to spawn. Those kind of things you have to bring all into the consideration before you start over the breeding program. But as I said, the most important thing is whether the fish whether the fish itself has value in the market enough to run a long-term breeding program. Because once you start, as I said, your investment in the first, let's say if you think you run a 5-year breeding program, do not start it. Because once you pass the 5 years breeding program, and you end it, all the investment that you did in the first year will be gone as well. So this is what I have in my perspective.
Yeah, thank you very much. So we have to select right species that has high market demand and also has the mating technology. Okay. Dr. Scott, do you have anything to add on Kun Amon?
Yeah, I just would like to support a little bit about the linkage between the marketing and genetic improvement program. At the basic information, we understand that the phenotype affected by the genetic and environment. If we do understand this, we can take every information that Kunamon said to be considered, and then we can make an appropriate design for the genetic improvement program. The first thing that we need to understand is phenotype, only phenotype that bring income, not genetic, not environment. The genetic and environment is about investment and cost. So if we understand this very well, we can set up the breeding objective, which means the target trait, to be considered how we can select the animal from the current generations and match them between male and female in order to get the next generation that need to be better, at least similar to the parents of them. Okay, if we do understand this, thing will be more easy, but still has challenge because every one of animal receive genetic half of their father and half of their mother. So not only just the father line, but also mother line that contribute the genetics value or merit for the animal for the next generation. So if we understand this, we can decide. So not just only the additive genetic effect from father and mother to be combined for the progeny, but also the difference between father and mother in different line can contribute something like non-additive genetic effect, like heterosis. I'm sorry that I talk about specific term a little bit, but that need to be understand more because this non-additive genetic effect cannot be transferred for the next generation. So we need to decide for gathering information to segregate the breeding value from non-additive genetic value and the other. And then we point to the thing that can be transferred from parent to the next generation, which means only the breeding value. And then we use that either for only trait selection, I mean one trait selection, single trait selection, or multiple trait selection, like we do selection index and weight them with the market considerations or the needs, I mean the demand in the market, which could be a first priority or more weight than the other. So things about this, not just only genetics, mathematics, statistics, but also merging with the market, the commercial need, and the situations in the real industry. Otherwise, it likely we work just only in a station, but when we send our animal out or from the station, they cannot be usable for competing in the market.
Okay, yeah, thank you very much. So it's like, you have something to add? No? Okay. So when I look at the time, is likely it's the time for break. What I would suggest is that you go out and take the break package and come back, eat in the room, and then we will continue the session. So for our foreign guests, don't leave us because we sacrifice speaking English for you. Okay, you may go and pick up the break.
10 minutes break.
No, maybe